Okay, now guys, we discuss the Probset solutions. Alright. So, unang nakasad lang lahat dito yung mga problem set natin. Okay, so let's try one by one. Okay, unang problem would be yung charged slab. So, meron tayong slab na merong thickness 2D. Okay, so drawing muna natin. Ang system daw natin, meron tayong slab na nakahiga sa YZ plane. Tapos, thickness 2D. Okay, so this is X, sabi niya. And this has to be Y by right-hand rule. This is Z. Okay? Okay, so yung slab mo would lie down here. Okay. Okay. So this is the midpoint is x0. This is xd. And the bottom part is x negative d. Okay. So malaki daw yung dimensions ng y and z ng slab. Therefore, it looks like infinite siya. Okay, so the slab has a uniform positive charge density rho. Okay, with that, rho is a volume charge density, so it's all over this volume. Okay, and then from that, alam natin that intuitively, yung field mo should come out of this slab. Okay. Okay. So next, the first question is to explain why the electric field due to the slab is zero at the center of the slab. So bakit daw yung electric field in the middle is zero? So let's break down this slab into two. Break down natin siya dun sa x0 line. Okay? Okay, so imagine this is the x0 line. And you are sandwiched by the two slabs. Okay, walang space sa gitna nila, no? Nilagyan ko lang ng space for visual clarity. Okay, in the middle, ang ano nararamdaman mong field? So superposition lang siya ng field coming from the first top slab and the bottom slab. Okay? And then you can imagine them as sheets. Downward yung sa taas. Outward, basically. Outward dapat siya. Kasi positively charged tayo, di ba? And then, from the bottom part, we have like something like this. Okay? And you notice that in the middle, they cancel out. So therefore, in the middle, mag-zero lang sila. Okay? Kasi may kino-contribute to na electric field with the same magnitude as the bottom slab. Okay? Same magnitude sila kasi same amount. Same amount sila kasi hinati sa gitna. Okay, so that's for A. And then using Gauss's law for B, find the electric field at all points due to the slab. Okay, so gawin natin siya dito. Gawa tayo ng Gaussian surface na ganito. So 3D tong Gaussian surface natin, no? Yung top, meron siyang area A. Okay, merong area A yung mga top panels, top sides. Okay, so E, ilang A yung maapektuhan ng field? Isa lang? Okay, kasi yung bottom part nga natin, 0 yan. So yung top part lang yung importante. Okay, and then Q enclosed over epsilon naught. But what is Q enclosed for this case? Okay, the Q enclosed would depend on how large or how tall our Gaussian surface is. Okay, if my Gaussian surface is somewhere here, okay, again 3D to, no? It extends inside the paper and enclosed siya. Okay, if we are going to use this, yung height niya would be x and the area on top is A. Then therefore, the Q enclosed would be rho times the volume that occupies, rho A x over epsilon naught. Okay, so therefore, my electric field is rho x over epsilon naught. And then vector x hat, as it points upward yung electric field ko at this point, so above plate, and in the bottom, okay. Bakit may X daw? I-reiterate natin. Bakit may X na nangyari? Because Q enclosed should be rho times the volume that I occupy. Okay? So, volume is length with height, and yung meron tayong area agad. So, that's A times a length na lang. Okay? Which is yung height nung Gaussian surface ko. Okay? And my Gaussian surface, inassume ko muna na maliit siya. Okay? Maliit siya. So, inside the slab siya ngayon. Inside the slab. And I need just a portion of the slab. Okay? So, nangyari, rho AX lang siya. Okay? So, burahin pala natin ito. So, this is X less than B. Okay? So, kapag itong second case naman na ginawa ko, that the Gaussian surface is larger than the slab, then, by Gauss's law, EA, rho A. Okay? So, we're above the x is equal to d line. Therefore, yung total charge would just be d. Okay? Kasi kahit na nandito na ako sa x is equal to d plus something, no, wala nang charge dito. Wala nang charge dito sa part na to. So, yung charge ko hanggang d lang siya. Okay, so the total enclosed charge would be this amount. Okay, so this amount lang. And that amount is the volume that is A times D. Okay, in this part, hindi siya A times D kasi onti lang yung enclose mo. And kung gaano karami, nakadepende kung gaano kakalayo sa x-axis. So, kaya may x tayo dyan. Okay, very important. So, we have our E to be rho D over epsilon naught. X hat. Okay? Kaya mapansin nyo, pag nandito ka na sa baba, mangyayari lang is that yung mga directions mo magre-reverse. So this for x greater than d. So we have rho x over epsilon naught tapos negative x hat for points that are negative d x 0, and then another one would be rho d, pangit naman nun, and then negative x hat. So that is 4 points that is less than negative. Okay, so tanong kasi sa atin is find the electric field everywhere. So we have to break it down like this. Okay, a simpler way of writing it is like this. Rho x over epsilon naught. Then my direction would be x divided by the magnitude of x. X hat. Okay? So ito, value lang nito 1 plus 1 or negative 1. Hindi. Actually, okay na pala yan. Mali. By hindsight, mali siya. Okay, ito ay okay na. And then, for points for x less than t. And then, rho b. Ito yung may kailangan pala niya. Okay. This is for x greater than d. Okay, so this accommodates the direction already. This accommodates the direction already. Kaya ko siya naisip na mali. Okay. Okay, that's for your first problem. Next would be, let's do this. Meron tayong solid conducting sphere with radius r that carries a positive total charge. Conducting sphere with r, total charge q. Gawin natin. So, ito ay r. Meron siyang positive q. And then it is surrounded by an insulating shell with inner radius r. And this is 2r. Okay, in insulating shell mo may rho. So that is volume charge density. Okay. And then we are asked to find the value of rho so that the net charge of the entire system is 0. Okay. Okay. So alamin muna natin kung ano yung total charge from the insulating sphere. So let me name that as Qi. And then that would be just the density times the volume. Volume for our case kasi rho siya. Again, rho. Pag sigma, kailangan mo lang A and so on. And then this is just rho times 4/3. The total volume with the charges are 4/3 2 r cube, and then minus yung inner sphere, so that's 4/3 pi r cube. Okay? Okay. So this can be simplified further into something like this. This is rho times 4/3 pi r cube. And then this is 8 minus 1. So that's rho times 4/3 pi r cube times 7. Okay, so that's our total charge that is in the insulating material. Carry, tapos ang tinatanong sa atin would be finding the value of rho so that the net charge of the entire system is 0. The net charge could be given as Q total. So that would be the Q coming from the solid conducting sphere plus Qi, the total. And if we want this to be 0, then Qi has to be the negative of Q. Okay, so solve mo lang dito. Nalaman mo na yung Qi must be equal to negative Q if you want this to happen. Then by that, I would have negative Q as my equal to Qi. That is rho times 4/3 pi r cube times 7. Okay, ito yung nakuha natin yung result kanina. And I just find my rho to be negative Q. Rho 4/3 pi r cube times 7. Okay, so this is my rho. If I want the net charge to be 0. Okay. Next would be finding the electric field in the regions 0 to R, R to 2R, and then R greater than 2R. Okay. From here, makuha ko agad na yung E from R less than R is 0. Okay? Kasi conducting sphere, conductor daw na sa loob na to. Therefore, the inside of the conductor is always has a 0 electric field. Okay, and then outside must also be 0. Kasi the net charge is, we force the net charge to be 0. Okay, so outside, wala ka na mararamdaman na electric field. So, ang problema na lang talaga natin would be finding the electric field in the middle of the insulating material. Okay, so let's do that. R. Okay, so nandun tayo sa region na yan. And then, let's just do Gauss's law. Okay, Gauss's law tells us that this is 4 pi r squared and must be equal to the u enclosed over epsilon naught. And this is equal to two terms. Meron tayo galing doon sa insulating sphere, ay galing doon sa conducting sphere, then from the insulating material. Okay, na-enclose natin lahat yung contribution ni conducting sphere kasi hanggang R lang naman sa conducting sphere and small r is greater than that. So the next term would be kung ilan yung na-enclosed kong charge from the insulating material. Okay, so paano ba to? Okay, so that's rho times the volume I have enclosed. So that's 4/3 pi r cubed and then minus 4/3 pi. Okay, gets kung bakit? Per epsilon naught. Okay, and then we use the value that we found for rho, which is this guy, negative q, and so on. So this is q over epsilon naught. Iwanan natin siya munang ganyan. Negative q over, sorry. Ay, ano ginagawa ko dito? Ba't mayroon dun? Okay, walang ro dyan. Na-muscle memory siya. Okay, going back. Oops, what happened? Okay. Let me continue. So may epsilon naught ako dito, tapos I have another 4/3 pi r cube. And then for the numerator, I could factor out the 4/3 pi factor. So I'm left with r cube minus capital R cube. Okay, and then I cancel that 4/3 pi. So final answer would be q epsilon naught. And then plus, well, minus q over epsilon naught times okay. You can let your answer be like this and you okay na yung gantong sagot. Pwede mo simplify, of course. There's no harm in doing that. Okay, and this is equal to, hindi pa pala ito yung final answer, no? E times 4 pi r squared. So, huwag kayong makakalimot dun sa left-hand side. Okay, and then therefore, E has to be Q over 4 pi epsilon naught r squared plus minus Q over 4 pi epsilon naught r squared, then multiplied by some factor, r cube, capital R cube, capital R cube. Okay, and then the direction would be radially outward. Okay. Paulit daw ng pagkuha ng rho. Balik tayo. We get this. Okay? Going back here, ang pagkuha ng row would be related to getting the whole total charge. So, yung total charge natin for the insulating shell would be rho times V. Okay? Rho times V. And then, V would be the total volume of that configuration kung saan merong rho. Okay? So, yung rho mo, it's just from R to 2R. So, therefore, ayun lang yung kukunin mo. Okay? Yung donut dito. Well, 3D siya kapal. So, hindi mo matawag na donut. Yung shell na lang. Ayan, shell. Ano pong nangyari sa factor ng 7? Hindi ko siya nalagay. Very good. May 7 pa dito. Hindi ko napansin. Sorry. Ayan. May factor pang 7 dito. Okay? Doon lang ba nalabuan kasi nawala yung 7? Okay, sorry. Ayan. Point out nyo na mali ako. Okay? Kasi may mga ganyan ako nakakalimutan. Okay, so may 7 doon. Di ko ginalaw yung 7, no? Alright. Sorry. Okay, I guess that's it for that question. Okay, and then letter C, as a general rule, the electric field is discontinuous only at locations where there is a thin sheet of charge. Explain how your results in part B agree with this rule. Okay, tingnan nyo at saan tayo merong sheet of charge. Okay, saan tayo merong sheet of charge? Sa tawag dito? At point R. Okay, sorry, at the region at R, sa surface ng conducting sphere, meron kang sheet ng charges. Okay, tama ba? Kasi that is a conducting sphere. So, lahat ng charges nun would reside on its surface. Therefore, sa region na R, meron tayong sheet of charge. And we can see that when we okay, from here, punta tayo sa at R is equal to R. Ano mangyayari? E becomes Q over 4 pi epsilon naught R squared minus Q 4 pi epsilon naught R squared. And this is R cubed minus R. Okay, R cubed, 7R cubed. And this is just 0. And it leaves us with Q over 4 pi epsilon naught R over R squared. R. And you can see that going from the regions between inside R and greater than R, magkakaroon ka ng discontinuity na ganito. Okay? And going away outside, no? Kapag pinlog in mo naman yung 2R dito, R is equal to 2R. Okay? So the second term, yung factor natin magiging 8R cubed minus R cubed over 7R cubed. And this is just equal to 1. Okay, so equal to 1. Magiging 1 lang to. Sorry. Magiging 1 lang to. And this 2 would be equal. So 0 siya pagdating ng 2R mo. Okay? And it's continuous kasi sinabi natin at r greater than 2r, yun pa lang yung na-infer natin na e is equal to 0. But we have seen that it is continuous kasi pareha siya ng value at 2r. Okay? At r is equal to 2r, 0 na rin siya. And that's continuous. Kasi wala naman tayo nakitang sheet ng charge sa r is equal to 2r. Yung meron lang na sheet would be coming from the r is equal to capital R na region. Okay? So kung naging 0 to, ibig sabihin walang discontinuity. But it isn't. Okay? It has a value. Okay. Okay, this 23.57 is just a counting problem. Okay, so calculate the potential energy U. So again, Q is K, Q, Q1, Q2 over R, the distance between them. So for this part, kakalculate mo lang kung ilan lahat ng interactions ng mga bagay-bagay. Okay, pwede mo sila i-group by kung sino yung same distances and so on and so forth. Okay, so ako i-group ko sila by the distance. Okay, so bibilangin ko ngayon kung ilan yung pairs ng charges that are separated by a distance d. Okay? So sa base part, meron kang 4. Meron kang 4 sa base part. And then the sides would give us also 4. And the top panel would also give us 4. So 4 plus 4 plus 4. So that's 12 pairs. 12 pairs of negative Q, this separated by distance D. Okay? So bilangin ko lang muna lahat. And then next would be yung mga positive charges naman, they are separated by Pythagorean theorem, square root of 2D. Okay? Square root of 2D. And how many pairs are that? Okay, so 1, 2, and those two corners at the back, so that's 3. And then this part also, sa front panel natin, we have this one. Na-count na natin to kanina. 2. Okay. And then, etong baba, hindi natin na-count. 3. Okay. So the total of 6 would be for the QQ charges. 6 for the QQ, separated by square root of 2D. And another one for the negative Q. Okay, square root of 2D din. Okay, so similar way lang. 6 din makukuha ko for the negative QQ. Negative Q pala. Okay? And then lastly, the far corners. Okay, so negative, they are in pairs of negative Q and positive Q. And you could see that there are 4 of them. 1, 2, 3, and 4. Okay? So yung 4 na malalayang corners. And by Pythagorean theorem, you can also find that they are separated by square root of 3D. Okay, and from that, I could just build my total energy. So I have Q squared over D. Q squared over D. And then, huwag na muna natin lagay si D. Para maging intuitive siya. Okay, and then, from here, lalagay ko na yung mga counting ko. So, 12 portions ng negative Okay? Kaya siya naging negative kasi mayroong excess negative. And then separated by a distance d. Next part would be positive lahat to. So 12 na lang din siya. 12 pairs ng d. Square root of 2d. And another one would be 4 pairs of square root of 3d. Pero negative. 4. Okay. And then you just plug in things. And you'd find that this is negative 1.46 q squared pi epsilon naught d. Okay. Next would be, in part A, you should have found that u is less than 0. Explain the relationship between this result and the observation that such ionic crystals exist in nature. Okay, so kapag mababa yung energy mo, favorable yun. Favorable for a state to go in. Okay, so yung mga tataas na energy, ayaw ng mga ano yun. Ayaw ng nature natin yun. Okay, dahil negative na kuha natin, nature prefers it that way. Kaya yung mga salt natin, and other crystals, mababa yung energy nila. Okay, and then yung mga radioactive materials mo, radioactive molecules, they are indeed mataas yung energy nila. Okay, so yun lang, chem. Okay. Let's have another one. So meron pa tayong tatlo. Two spherical shells have a common center. The inner shell has a radius, ang pangit naman ito, naka-centimeters. R1, which is 5 centimeters. And then the charge accompanied by that spherical shell is 3 microcoulombs. The outer shell has a radius 15 and charge negative 5 microcoulombs. So they are spread uniformly, yung mga charges mo over the shell. And we are asked to find the electric potential due to the two shells at the following distances from their common center. Okay, so 2.5, 10, and 20 cm. Take V0 at very large distance from the shell. Okay. For a spherical configuration of charges, alam natin that the electric field looks like kq over r squared. Okay? For any spherical object, di ba? Ganito yung makikita mo pag malayo ka dun sa loob ng charge. Malayo ka sa surface ng charge. Okay? Ito yung makikita mo. And then, of course, this would result also to a potential. Potential that is kq over r. Okay? And then, for a shell, alam natin that E0 inside of that shell, kasi by Gauss's law wala kang ma-enclose na charge, di ba? Kasi nasa surface lang ng shell lahat. Okay, so and this would result to a V that is constant, tama ba? Can be any constant, can be 0 also. But the point is, constant siya para pag derivative mo to, lalabas to. Okay? And in the same way, ganun din dito sa taas, the derivative mo siya, ito yung makukuha mo. Dahil ayun nga yung formula nila. Okay? Now, potential is always continuous. Continuous ang potential. Well, hindi pala always. May cases na discontinuous siya, pero that's for another, hindi nyo kailangan aralin yung mga ganun bagay. Okay, but sa mga case na inaaral natin, the potential is continuous. Okay, So for r greater than the radius of the spherical shell, ang makukuha mo na potential is kq over r. And then for r that is less than r, makukuha mo ay v, some constant. Okay? So if you want it this constant to be continuous, you can just choose it to be the value of the potential on the surface. So kq over r na lang. Okay? So para equal sila at r is equal to r. Okay? So at r is equal to r, ito siya. Okay? So equal silang dalawa. And that makes it continuous. So ganun yung gagawin mo. Okay? So the potential inside the spherical shell, or where the electric field is 0, yung potential mo, it will just take up the value kung ano yung nasa surface. So kq over r in this case. Okay, so let's examine the distances that we have. So for A, ang distance natin would be 2.5 cm at A, at 2.5 centimeter. At 2.5 centimeters. Wait lang. We are inside both spherical shells. Both shells. Okay? We are inside both shells. So the V total would just be equal to two constants. So K, Q1 over R1 plus K, Q2 over R2. Okay? So R1 is given by 5 centimeters, so that's 0.05 meters. And R2 is given by this one, 15 centimeters, so that's 0.15 meters. So you just plug in things and you find that this is equal to 240 kilovolts. Okay. And then at B, at ano yung pangalawang tanong? Sorry. At 10 centimeters, at 10 cm, at 10 cm, nasa loob tayo ng outer shell, but we are outside the inner shell. Okay, nakakalito yun. So let's write it down. We are outside of inner shell and inside of outer shell. Okay, so the V total would just be for the inner shell, K Q1 over R, where R is 0.10, and then plus KQ2. We are inside the outer shell, so that's constant pa rin yung gagamitin ko. So we have KQ2 over R2. Okay, so nagbago dito sa part na to kasi nasa outside na tayo ng inner shell. So yung dependence natin would be 1 over R na. Kung gaano tayo kalayo dun sa shell mo. Again, conversion, don't forget. So this is negative 30 kilovolts. And lastly, for the last question, last distance, that will be 20 centimeters. So 20 centimeters is outside both, okay? Both shells. Both shells. Okay? And that gives me KQ1 over 0.2 plus KQ2 over... Okay guys, mali yung conversion ko. 0.02, 0.02. This is 0.01, 0.01. And dito wala namang conversion. Okay? Sorry. Ngayon ko lang na-realize na 100 centimeter ay 1 meter. So, dapat pag minultiply ko by... Yan. Okay. Ay! Nalito ako. Tama pala. Ano ba yan? Sorry. Convert nyo na lang sa Google. 0.1 nga. 10 centimeter. So, kapag gagawin ko siyang 100 meter, multiply ko by 10. Okay? So, tama. Sorry. I'm confused. So, yan. May mga bagay na ganyan. May mga trick questions siguro sa exam na may mga conversion muna. Okay, so don't forget to use Google. May may conversion naman. And this would result to a negative 90 kilovolts. Okay. Okay, so that's for that question. Sir, tanong ko lang po, bakit hindi mas zero yung magnitude? Ang niya, no, counterintuitive niya, no? Okay. Kasi, dito sa pangalawang tanong, we are inside the outer shell. So, constant tong second term mo. So, that's what makes this guy large. But if you go here, sabihin natin 100 cm ilagay mo, liliit tong bagay na to. And it would decrease to 0 as you enlarge this values. Okay, decreasing siya. Decreasing siya as you go along, increase your R. Okay, so from here, sa inside part would be from 5 to 15 centimeters, it's decreasing. Okay, from 240, bababa siya. Okay, again, naging counterintuitive siya kasi constant ka sa loob ng constant ka sa pag nasa loob ka ng dalawang shells. Okay, so hindi nag-a-apply yung statement na mas lumiliit siya. Sorry, basahin ko na maayos. So, hindi po nag-a-apply yung statement, mas lumiliit siya is relative to the system po, hindi sa origin. Yes. Kaya lang siya KQ over R kapag kino-consider mo yung mga your outs, you're looking at charges or charge-like distributions. Okay? KQ over R. But when you're inside configurations such that the electric field is zero, the potential becomes constant. Okay, so yes, relative to the system ito. Kung gagamitin mo yung kuwari, electric field natin for a slab or for a infinite plane of charges, so that would be sigma over 2 epsilon naught. Okay. So the potential for this part is V sigma x over 2 epsilon. Okay, so assuming exact yung direction nito. Tulad nung kanina, pointing to the x direction. Okay? Kasi 'di ba derivative ng v would result to r would result to e. So derivative nito would result to e. Tama? Okay, and if you would look at this, yung infinite pag nilakihan mo yung x mo magiging infinite lalo to. Okay? Magiging infinite to. So it's not generally laging lumiliit siya pag lumalayo ka doon sa charges mo. Okay, so be careful, be careful. And then let's do this other part. Parallel plate capacitor has the volume. Okay, drawing muna tayo ng capacitor. Meron kang parallel plate. And then another one here. So this is Q and this is negative Q. And then you fill it up with the electric material like that. And you plot out the electric field. Okay, so the electric field inside is like this. Outside, for the positive Q, pa ganun siya, but yung contribution ng negative Q, pa ganun. So, outside, it's just 0. Inside, meron kang pababa, given by sigma over epsilon naught. Okay, so 0 outside, bali kapag gumawa ako ng Gaussian surface na ganyan. Okay. The electric field that I would get is, let's call this A prime. Okay, A prime yung area ng top plate ng top part ng Gaussian surface ko. So I have E times A. Okay, hindi 2A kasi 0 sa taas, dito lang ako may value. And then that must be gamit to yung gamit yung formula pala, sabi niya. Okay, Gauss's law as stated in equation 24.3. Basically, yung ganito yung itsura nun. Yung K, E, dA over Q free epsilon naught. Okay, so let's do that. K, E, A prime must be equal to, ano na enclose kong charge? So this part, okay? So this part is just Q over A, density ko. Density ng plate ko. So, may A na area dito sa parallel plate. So, that has its own density times A prime. Tama? Nagets nyo bakit? Epsilon naught. Okay? And then, this results to E. Q over A epsilon. Okay? So, A prime cancels out. Okay. And this is okay. I mean, this is expected kasi ang usual form natin, 'di ba, sigma over epsilon naught. Kapag dalawang plates. Kasi dalawang sigma over 2 epsilon naught, pag-add mo sila. So that's sigma over epsilon naught. Okay, and sigma is just Q over A. Okay, so that's okay, nice, gets. But this time may K lang dahil may dielectric. Okay, then we have to use the electric field determined in part A to calculate the potential difference between the two plates. Okay, so let's say that this is A, this is B, and the potential VAB is just the integral AB E dotted with DL. So the DL is just yung path ko papunta dito. Okay? So this is just constant lang naman yung sagot ko. So Q over A, lalabas lang lahat sila. Epsilon naught. And this is just DL AB. Okay, we have a question. Okay, di po ba negative yung integral? Let me double check. Tawag dito. Sige, double check ko lang. Para sure tayo. Okay. Hindi pa. Hindi. VAB, hindi. Okay, tama ako. Tama yung sinulat ko. Okay? So, tama to. Ito yung formula sa libro. Okay. So, this part is just your distance. So, that's QD over A K epsilon naught. Then, okay, given naman yung distance between the plates. And then we need to find use the result of your part B to determine the capacitance of the capacitor. Okay, so we have a potential V is equal to Q D over A K epsilon naught. But C, Q is equal to CV, and I have I can get QV, Q over V, to get C. So from here, i-rearrange ko lang such that I could isolate Q over V. Q over V must then be equal to A K epsilon naught D, and further rearrange it K epsilon A D A over D. Yan. So this part is what we know to be the capacitance of the parallel plate capacitor without the dielectric. So this is just K C naught. And this is what we know. May formula tayo nito. Okay. So may tanong tayo. Sige, i-clarify nga natin ito. Okay. So ang tanong sa atin ay, para sa lahat, no? Bakit ganun, sir? If V greater than 0 as we go from positive plate to the negative plate, that means that the negative plate is at a higher potential po. Okay. So we have to answer that. Naghahanap ako ng example na para intuitive sa atin. Okay. So sige, go back. Okay, okay. So tanong sa atin, bakit ganun po, sir? If V is greater than 0 as we go from the positive plate to the negative plate, that means that the negative plate is at a higher potential po. Yes. Okay, guys, hindi potential energy ang electric potential, okay? Okay. And the zero value of the potential is depende sa atin. Okay. So ano nga 'di ba? Ang potential nga nung ang potential, sabi ko nga kanina, ang potential nung nasaan yun? Sige, balik tayo nasaan. Mahanap. Ito. Okay, ang potential ng isang infinitely charged sheet is given by this. And as you can see, kung nasaan yung sheet, doon zero yung potential. And kung saan walang charge, doon malaki yung potential. Okay? So, hindi siya iniisip natin na dapat doon sa mas positive charge. Dapat doon mas malaki yung potential mo. No, no, no. It's not like that. The 0 point of the potential is arbitrary. Okay. So, hindi pa tayo magkakamali nun, sir, kung laging arbitrary yung Hindi, hindi. As long as you are mathematically consistent, hindi ka mamamali sa pagiging arbitrary niya. Okay? So this is different from potential energy, na iniisip natin na Mas malaki dapat yung potential energy kung saan may positive charge. Okay. So that's not the case for potential. Okay. So you just have to satisfy yung mathematical relations ni potential at ni electric field. Okay. So okay. So lastly, at ang cute ng cute ng example na to. Sa mga keyboard natin, no, merong mga small metal plates that nagiging parallel plates sila. So kapag pinipindot mo yung pinipindot mo yung key, yung plate separation bababa, therefore the capacitance would increase. Okay, so yung circuits natin, tinitingnan niya kung how much the change in capacitance, and kapag naabot niya certain threshold for that to change, magre-register siya ngayon ng signal that the key has been pressed, no? Okay, for this example, the area of each metal plate is a 42 square millimeters, and the separation between the plates is 0.7 millimeters before the key is pressed. Okay, so calculate lang natin yung capacitance for the first part, yung hindi pa siya pinipress. So that is C epsilon A over D. And you just plug in your values. You'd find that this is 53.1 times 10 to the negative 13 farads. Okay, and then the next question would be finding out if the circuitry can detect a change in capacitance of 0.25 picofarads. Okay, so gaano raw kalayo yung pipindutin mo para ma-detect ng circuit. Okay, so let's lagyan ng C note. Okay. So for that to happen, kailangan mo mapataas yung capacitance to a certain degree from your C naught. And that degree is given by 0.25 picofarad. So therefore, the new capacitance must be your original capacitance plus 0.25 picofarads. Okay? 0.25 picofarads. Kasi less than this, I won't detect that. The circuit won't detect that. So you need to increase your original capacitance to this threshold value. Okay, so you then plug in things. Just plug in things, and this is still epsilon not A, pero this time you have D prime, and you have D's value for your right hand side. Okay, meron kang values na ganito for your right hand side. And then you plug in things. Okay, plug and play na lang to sa calculator nyo. And this would result to a 0.224 millimeter, okay, of distance. So that's how your some of the keyboards are engineered. Okay, so that's it for all the Probset questions. And do you have any more questions, guys, from yourselves na inaral nyo for the exam on Saturday? Okay, parang wala na. Sige, kung wala naman na, edi dismiss na tayo. But kung meron, you can always consult on Canvas. Okay, message nyo na ako sa Canvas if you want to consult. Alright. Good luck sa exam, 4 to 6 p.m. By 4 to 6:30. Pero 2 hours lang yung exam, no? 2 hours lang yung exam. Open lang siya from 4 to 6:30. Okay, so kunyari, nagme-merienda ka pa ng alas 4, pwede ka mag-start ng 4:15 to end at 6:50. That's okay. Okay?
Thank you, sir.
Okay, sige. Dismiss.